Hey you, where am I? A second ago I was talking about complex numbers. Now I'm here. Wait, you don't know about complex numbers now, do ya? Well, let me teach you. Right after I find my way out of this place. Right, I'm back. With a better green screen. Alright, so complex numbers. Let's have a look at them. Well, a complex number is made up of two parts. It has a real part and an imaginary part. A real part, as you may know, is a real number. As represented here, it's a 3. So it's 3 on the number line. It can be 3 to infinity and back. Well, what about imaginary numbers? We have a 2i here. Now, what does that mean? We've seen ABCs before, and they can be equal to whatever the person wants. You can readjust the equation to find out what it is, but it's a bit crappy. What we have is a predetermined value. I is equal to the square root of -1. Now, what is the square root of -1? Well, it's a third, but it's also an odd number. See, it's impossible. Mainly for the fact that means if you squared I, you would get -1. And it's impossible to have a number that is squared to give you a -1. And at first thought, you're like, why? Well, we know that any number times another number is always going to be positive. 2 times 2 is 4. -2 times 2, that's also 4. Because the negatives cancel each other out, right? So, what gives? How do we make a square number that doesn't work? Well, that's the thing. We have to play with the square root of -1 because otherwise it's mathematically impossible. So it's represented as I. And the reason why we have an I as a value is because the square root of -1 comes up way too much. It's just everywhere, honestly. Too many places, not enough time. So, how do we use this? Well, one of the easiest ways to chart a complex number, to show it, to visualize it, is to put it on one of these. Now, a Cartesian plane is very simple, you know? You have a number going from 1 to 10, up, -1 to 10, down, sideways, cross, whatever. But we're going to rename these axes. So on the x-axis, which is our horizontal value, we're going to call that the real axis. Now the real axis is, as you would think, it's got all the numbers that are real on it. Whereabouts we call the y-axis, the horizontal one, the vertical one I mean, the imaginary line. Now this lets us chart something. So if we have our example from earlier, 2 plus 3i. What is that? Well, we go 2 spaces across in the x direction, and then 3 spaces up in the y direction. 3 on the imaginary, and 2 on the real axis. Easy, simple, fun. But what now? Well, we have this point. What can we do with it? Well, the best thing about this is it gives us a point to go to a different form. And this form is called polar form. Why is it called polar form? Search it up. Right, so we have polar form now. And polar form, we need a few more lines. So instead of just being a point on the thing, we're going to make it into a triangle. We're going to have a line from 0, 0 all the way up to the point. And then we're going to have a line from the point down to the x-axis, and then from there all the way down to 0, 0. So now we have our base, we have our height, and we have hypotenuse. Now this is where we use some old math. So, we all know about trigonometry. And then, what's the basic premise? The thing that you get taught at the very start, Pythagorean theorem. We know that we have a height of 3. And we know we have a width or a length of 2. So, we get this triangle. Now, we can use an easy formula of a squared plus b squared is equal to c squared. I'm going to call this n squared because other ways we're using n as the hypotenuse. Just get used to that. So, it's equal to n squared, which means we have 4 plus 9. That is then going to be equal to 12 to the square root. The square root of 12. I don't know what that is. I'll put it on the screen now. Right, so we have that. Now the other thing we need to use is more trig, but to find a very specific thing. The angle. It's the angle from the 0, 0 point. The theta of the 0, 0 point. Right, so how do we find this? Well, we use simple ratios. We can use tan, sine, cos, whatever you want. I'll be using tan, it's the simplest. So an opposite of 3 and an adjacent of 2 gives us 1 point something? I don't know. Find it out yourself. But there's the angle. Boom. Now we have that. So now we have this equation. And you might be like, what the hell is that equation? Well, we can see we have the n value, a hypotenuse, and then an angle. That angle is representing our 0, 0 theta, which is then going to be that number. Right? So we have this number now. Why are we using polar form? Well, rectangular form, if we go back to that, we can see it's got an issue. Adding and subtracting, really easy. Follow basic algebra, and we add the i's together and add the real numbers together. Boom. But when you multiply, you get a -1, because I squared is going to be equal to -1. And you can go through this whole tipsy-turvy. But if you got one imaginary number, and you have to times it a bunch of times, use polar form. Easy. And by using polar form, we can convert to a completely different thing that I won't talk about right now. So, what is polar form? How do we multiply them together? Well, we need to get the two values of the hypotenuse. The hypotenuse, let's get a value of 5 and a value of 4, right? So, 5 times 4, 20, easy. Now, for our angles, for the 5, we're going to have it at an angle of 30. And for the 4, we're going to have an angle of 45. We add those two angles together to then get 75. That's right, you guys can do basic math. So, now that we have 75, what do we do with it? Well, we put it into our normal thing. And then if we really wanted to, we can draw a point of the grid. But that's like all the way up there, and I don't want to do it. So, we have this value now. But the key thing to remember when it comes to complex numbers is when you're multiplying, you have to keep the angles consistent with the multiplying rule of when you have two negatives, it becomes a positive. So, if I had an angle of -10 and an angle of -20, and I was timesing them together, I may be minusing them in practice, but in actual math, when you work it out, you have to follow that rule. So they cancel each other's negatives out, and they give you 30. Boom. Easy. If there's only one negative, just minus it. Or, in the case of division, just minus it. If you have a -1 divided by a +1, because that divided becomes a minus, you have to just cancel both of them out. You got a positive. Boom, shakalaka, we're all happy. So that is the two forms of complex numbers. That's all I got for you. But before you leave, got some questions, right? First one, I would like you to that was good. I'm going to use that because I'm not recording.